And by pause, I mean finish and then do a whole new video, apparently. Oh, okay, whatever. So 6, 1, 25. I have negative cosecant of t divided by sine of t, and then plus cotangent of t divided by tangent of t is equal to -1. Yep. All right. I have in my notes here that it says I'm going to only do it my way now. Because I'm so fed up with my math lab, and so should you. You should go send like a complaint or something, right? Like, my math lab, change your ways, and then you'll probably get ignored, like I always get ignored. So that's whatever. Anyways, so I'm gonna go ahead and do it my way, and it'll be great. And I'm gonna start with the complicated side. My first instincts is to change everything to sine and cosine. It's just an easy go-to, and a lot of times it cancels a lot of stuff. So that's exactly what I'm going to be doing here. Okay, cotangent is cosine over sine, then all over tangent, which is a sine over cosine. Now, this is technically like over 1, and so when I take and flip it to the top, what I'm going to get is, here we go, I got negative 1 over sine, and then I have a 1 over sine. On this side, I've got cosine over sine, and now I've got cosine over sine. When I mush all these together, I get 1 over sine squared, and then I've got cosine squared over sine squared. Yep. Notice that I have a common denominator, right? So now I can mush my numerators together. So I have this kind of guy going on right now. My handwriting has never been good, but you can see how it's like really not good right now, because there's so many letters instead of actual math, I suppose. Okay, so that's what we have. Well, if you look here, what we actually have is something a little bit better than what you think. Okay, what I'm going to do is I'm going to change this a tiny bit by factoring out a negative sign. Now, I know that is very strange, but I'm doing this on purpose because I see the Pythagorean identity here. Right here, this thing. This is what the formula is. That's not quite it. It's close, but it's not quite it. This is it. This is equal to sine squared. And guess what happens? They cancel. Leaves a -1. Okay, we did it. So verified. Yay. I did not write down what my math lab wanted. I did not, because I am actually done with that, okay? I say that like going forward into new sections in this chapter is actually better. They don't do this hand holding nearly as much. Okay, so that's a good relief looking forward. But this section is just tough, man. It's tough, and I've given you the tools in order to overcome it. What I'm giving you now is the math that you actually need for later in this course and in calculus. In fact, what you're doing here is super important because it's not like you'll use it every day in calculus, but you'll probably use it like every other day, or maybe like twice a week or something, where you're like moving these trig identities around in order to get a better result. So sometimes they'll do polynomials and sometimes they'll do trig. If there's any amount of trig in calculus, you're going to be doing this stuff for sure, because you need to simplify it down to a particular format that would make more sense. Okay, so it's a very, very important skill, and I'd rather focus on skills right now rather than just what my math lab wants. I'm sorry, I'm going to keep harping on that all the time here. Okay, so I'm going to start with this side. I don't know what my math lab did, but I'm going to start with this one because it's a tiny bit complicated, I guess. So this is going to be 1 over cosine and 1 over sine 1 over cosine, 1 over sine. Awesome. What I'm going to say is that I want a common denominator. Okay, hold on. Am I doing the different problem? Oh, no. I'm sorry, I was looking at the wrong part of the page. Yeah, we're good. Yeah, so this is great. I want a common denominator for here and there. This is where it gets a little weird. This guy needs, I'm going to use a different color for a second. This guy needs a sine over sine, okay? This guy needs a cosine over cosine, okay? This one here needs a sine over sine, and this one here needs a cosine over a cosine. So that's what I'm multiplying by. That's a whole lot. And so then I have a sine plus a cosine all over a sine times cosine. Notice right here, I just kind of did my common denominator kind of thing. Common denominator. Control Z. Okay. And then down here, same thing. I got a sine minus a cosine. And then again, all over my common denominator sine cosine stuff. Awesome. So what happens is that when you flip this to the numerator, these denominators cancel, and you actually just have this kind of fraction left over. So let me rewrite that now. Again, I might not be doing it any way at all like my math lab. I don't know, because I'm just doing my own thing over here. Now, this is a good time to pause. Okay, when I need to look back to see what I want. This to this, it's actually closer than you think, because these ones here they're telling me that these guys need to be canceled. As in, like, if I divided it by cosine, ... how do I get a sine into a tangent, right? Well, you divide it by cosine again. So what I'm going to do, and this is, again, kind of weird, I'm going to multiply it by 1 over cosine in both the top and the bottom. Okay? And that's going to distribute to all those terms. So then what I have now is a sine over cosine plus cosine over cosine, all divided by sine over cosine minus cosine over cosine. Obviously, these are going to cancel, and they leave a 1. Sine over cosine is a tangent, plus 1. Sine over cosine is a tangent, minus 1. Verified. Cool. And yeah, I did not use x at all, apparently. I just gave up on it, so oh well. I have 1, 2, 3 more problems left, and they get kind of tricky at times. So I can't do every single homework problem, but I'm trying to do, like, good ones, ones that stand out to me. So that's a tangent, that's a cosecant squared, and then we have another tangent, and then this is equal to cotangent. Okay, well, the first step is pretty obvious, I feel. Factor out the tangents. Leave them behind. A cosecant squared minus 1. Now, as soon as I see something squared minus 1, I feel like it's a Pythagorean identity. And it is. If you go and, like, move some around, the one with the cosecant and all that stuff, what you actually yield out of that is a cotangent. So this is not a straight formula from the formula book, but it's pretty close. You just move it around to make it work. So that's Pythagorean for sure. Okay, well, now what I have is this guy is technically 1 over tangent squared, of course, because cotangent's the flip with tangent, that kind of thing. Well, this tangent's in the top and that's in the bottom, and so it cancels with one of them. So I got actually 1 over tangent now, which that's just a cotangent. I am, like, really sure that my math lab is not going to like this last little bit of steps right here. It's probably fine with this, but this thing right here is going to be like, so I don't know. That's just the way I see it, okay? Because I want to keep it as simple as possible. So let's keep going. Next one. 1 minus, I've got sine squared theta. There we go. 1 plus cotangent theta is equal to cosine. We'll definitely start with a more complicated side here. Okay. I feel like I want a common denominator, but I'm pretty sure I'm looking at this problem here, and I was staring at it forever about how to get this thing to work. Like, here's the big picture. I needed to get to a plain old cosine. How do I even do that? So watch this nuttiness here, okay? And I don't think I used my math lab to help me here, but I might have. Because, like, what I'm going to do here is just, like, off the wall, okay? You ready? I'm going to multiply by 1 over cosine in both the top and the bottom, okay? Now, you are definitely wondering, why? Why are you doing this, Chad? It's called the conjugate. Conjugate. There, I hope I spelled it right. Conjugate. And we're going to have this a lot more later in this course. But the conjugate's like, it's basically canceling the middle term. It's making that, I don't know what they call it. It's not a perfect square, but something like that. You'll see here in a second, okay? So this is a very particular step. Now, what I have in the top, and what I'm going to do is like just leave it alone. I could start distributing and, you know, having a jolly good time, but let's just leave it alone for a little bit because I want to focus on the bottom. So I'm going to FOIL this essentially. So I got, there we go, FOIL. So I got 1 times 1 is 1. Got 1 times the negative cosine is a negative cosine. Here, I'll even write it out this one time, okay? And then I got cosine times 1 is a positive cosine. And I got cosine times the negative cosine is a negative cosine squared, okay? Now, these guys cancel. That was the point of the conjugate. That's what happens there. So let me just rewrite all this stuff in the top. We'll fix that here in a second. So I got 1 minus cosine squared. You know what's funny is that I'm kind of happy I didn't just... Oh, hold on. I messed up something. Did you see it? Right here. There's no square right here. That's just a normal cosine, okay? I messed up. There's not a square there. Not a square. Because I was about to start canceling things that should not be canceled. So hold on. That was totally my mistake. Okay. Now, if you look right here in the bottom, this is a Pythagorean identity. And so what we have now is a sine squared, 1 minus cosine, and then all over sine squared. So that's a sine squared. These guys cancel. So I got 1 minus, and there's no more denominators, so I could just, you know, write it all on one side, I guess, here. Distribute your negative. So I got 1 minus 1 plus cosine. Well, these cancel, of course, and it leaves a cosine theta. Awesome. Cool. That was a long process right there. I have only one left, and this is by far the most complicated one, so here we go. 6, 131. I just really wish my stylus would cooperate because I have to write so slow and like deliberate in order for this thing to like read anything. I've tried to adjust settings. It's just, I don't know. Something's just not happy with it right now. Okay. There we go. So we got something wild and crazy. And we need to get to a cotangent, and that's it. Okay. So, how am I going to even get this thing to work? Well, common denominator. Yep. I'm going to multiply this by the 1 over secant. 1 over secant. And over here, I'm going to multiply it by tangent and tangent. That way you have a common denominator. So here we go. I've got 1 minus secant, and it's actually squared because there's like 2 of these guys. Notice that it's not secant squared, it's squared like the whole thing. And then I have a tangent squared. And then it's all over one common denominator of 1 minus secant times tangent. Okay. Now, what do we do? I'm actually going to expand this numerator right here. So what it is 1 minus secant, 1 minus secant. And what I feel is going to happen is something is going to cancel here in just a second, okay? But for right now, I'm going to like leave the denominator alone. Let's just go ahead and FOIL this thing out so you know how this works. And you can actually get the answer without having to do all this crazy math. So there's 2 secants. 2 negatives make a positive. Secant squared. I really wish my handwriting was better for you. My hand is hurting because of this deliberate, very constant writing. But hey, how can I complain when we're doing cool math? All right. So this is the time to pause. I want to see what I can do to start getting this thing more simplified. Like I'm supposed to get it just down to cotangent, right? Well, like these guys right here, like I'm going to use a different color. These guys right here have a certain feel to them. And in fact, this has a formula that is a Pythagorean identity. You know what that is equal to? It's equal to 1. Isn't that weird? So what I'm going to do is I have now 1 minus the 2 times secant plus 1. And then I have all this craziness in the bottom, which I have not yet taken care of. We'll get to that in a minute. Notice that these 1s here, they don't cancel, they combine. So like combine like terms kind of thing. All right. Still, I am not going to cancel. So I'm going to, now that I did that, I'm going to now factor out the 2's to the front, leaving a 1 minus secant. And look, we have a 1 minus secant in the bottom too. Now we can finally cancel. 2 over tangent, 1 over tangent or whatever is cotangent. So now 2 over tangent is 2 cotangent. And there we go, verified. I hope that you're also seeing that me leaving like the letters off is actually kind of faster. For you, it just, again, it's just a shorthand. I don't recommend it in every professor's class. They might say, no, you forgot the theta. I don't know. I don't. You're just trying to get the answer, man. Okay, that's all I got. Thank you very much, and have a great day.